We will do questions 4 through 6 on our assignment here, the first one. So let's take a look. I went ahead and factored. So in the numerator, there is a 3 in common, so factor it out of 3. We're left with 3 times x squared minus 4. X squared minus 4 is a difference of squares, so we can factor that into x plus 2 times x minus 2. So we factored, and now we look for holes. Holes are where factors cancel. Well, no factors cancel, so there's no holes. Zeros are values of x that make the numerator equal to 0. So we see if x was negative 2 or x was positive 2, that would give us our zeros. Let's go ahead and put those points on the graph. Both of those are just multiplicity 1, which is odd, so it's going to cross through here. So we'll put a point at negative 2 and a point at positive 2. Vertical asymptotes, that comes from the denominator values of x that make the denominator 0, which is 0, and it is multiplicity 2, which means they'll go in the same direction on either side of the asymptote. Sometimes we've said it will bounce off infinity. So we have that drawn in there, x equals 0. And then for horizontal or slant asymptote, we look at the degree of the numerator compared to the degree of the denominator. They are both 2. And so when they're equal, there's a horizontal asymptote at the leading coefficient of the numerator over the leading coefficient of the denominator, so y equals 3/4. And so we have a horizontal asymptote drawn there. Now we can go ahead and graph. Our vertical asymptote splits this graph into 2 sections. We have to the left and to the right. And so what we will do is we will kind of think through where can the graph be or where can it not be. So we'll go in black here. So either our graph could be here, and we actually see that that cannot work because it has to cross through this x-intercept. And so as we look at this will be a horizontal asymptote here. It will cross through this 0, and then it will get closer and closer to the vertical asymptote. We know from the multiplicity 2 that on either side of the asymptote, it will both go down or both go up, so they both go down here. And so this comes up, and it will go through here, and then get closer and closer to the horizontal asymptote. Question 5, start by factoring. X squared minus 1, that's a difference of squares that can factor to x plus 1 times x minus 1, so our factoring is finished. So we went ahead and factored. Nothing cancels, so there are no holes. The zeros come from the values of x that make the numerator equal 0, so that's at negative 1 and positive 1. Vertical asymptotes are values of x that make the denominator 0, so that's at x equals 2. So we have that written there. I guess, sorry about that, we can just go ahead and start putting those on here. So the zeros, there's a 0 at negative 1, and 0 at positive 1. Vertical asymptote is there at x equals 2. And then we have a horizontal or slant asymptote. We look at the degree of the numerator compared to the degree of the denominator. Degree of the numerator is 2. Denominator is 1. That means we have a slant asymptote, so we do long division. And just looking here at our long division question, I have x minus 2 divided into x squared minus 1. I did put this extra 0x here just to keep that placeholder there. And so we think to ourselves, what times x gives me x squared, and that is x. And then we multiply, so x times this whole thing gives us x squared minus 2x. And then we subtract, so x squared minus x squared is 0. 0 minus negative 2x is positive 2x, and we bring down the negative 1. And then we divide again. So x times what gives me 2x, and that's 2. And really, as long as we have that, we can stop there. I went ahead and did some multiplying, but we didn't need to. And so our slant asymptote is at y equals x plus 2. So that's why I have that black slant asymptote in there. It's at y equals x plus 2. We start at 2 on the y-axis, and then we have a slope of 1, so up 1 over 1. So that's our slant asymptote. Y-intercept we can find by plugging in 0 for x. So coming up to our original, if we put a 0 in for x, so 0 squared and 0, that's negative 1 over negative 2, which reduces to 1/2. And so we have a y-axis, y-intercept at 1/2. Once again, we use our vertical asymptote to split the graph into two sections. So we have the left and we have the right, and we want to graph there. So as we think to the left, this one's probably pretty easy to see. It can't be this branch because it doesn't hit the x-intercept. There's no x-intercept there. So it can't be that one. And it definitely can be and is this branch down here because it goes through our x-intercepts and our y-intercept, and we have the asymptote there. And then there's not a lot of room here, but then our upper branch, our other branch would be here. And I should mention that's we have our vertical asymptote, which is multiplicity 1. So on the left, this went down. So on the right, it goes up. We also could have thought through it actually can't be this orange section because there's an x-intercept on the orange, but there's not supposed to be an x-intercept. So there's the graph of our function for number 5. And the last one for our first assignment here, question 6, there was no factoring we could do. Nothing cancels, so there's no holes. Zeros come from what makes the numerator 0, so that's 0, and it is multiplicity 2. So let's go ahead and put at 0, we'll put an x. That reminds us it's multiplicity 2, so we'll bounce. Vertical asymptote is at x equals 1 because it's what makes the denominator equal 0. So, sorry, at x equals 1. So we have a vertical asymptote at x equals 1. Horizontal or slant, we look at the degree of the numerator compared to the degree of the denominator. Degree of the numerator is 2. The degree of the denominator is 1. So the degree of the numerator is greater, which means we have a slant asymptote. And then we do our long division. So we have x minus 1 into x squared. And notice here in the orange, I have those 0x plus 0. Those are just placeholders to help us line things up correctly. So we think, how many times does x go into x squared? It goes in x times. And so then we multiply x times x minus 1, and we get x squared minus 1x. Then we subtract, and we get x squared minus x squared is 0. 0x minus negative 1x is 1x. And then we think, what times x gives me x? And the answer to that is 1. And so we have x plus 1, and that's all we need to get our slant asymptote. So our slant asymptote is y equals x plus 1. So we want to go through 1 on the y-axis and then a slope of 1. And we have that slant asymptote drawn in there. And now we can graph our function. We have one vertical asymptote, which splits this up into 2 sections. And so we have to see where the branch goes on each side of that vertical asymptote. And so we can think through, well, what works? Well, if we try this one right here using our slant asymptote and the vertical asymptote, that doesn't work at all because we don't have an x-intercept there. And so it must be this bottom section. We come to this 0 here, it's an x, that reminds us it was multiplicity 2, so it has to bounce and then come down here. And then to the right of the vertical asymptote, this vertical asymptote was at x equals 1. It was just multiplicity 1, and so they need to go in opposite directions. So since to the left it came down, the right needs to go up. And then we have this has to turn and then follow the slant asymptote. And there is the graph for number 6.